To understand how Triangulum thinks, start with one simple idea. It does not wait for you to speak before cognition begins. Most artificial intelligence works in episodes. You ask a question, the system processes it, produces an answer, and then essentially waits. Triangulum is designed differently. Its central innovation is what we call processual continuity, an ongoing cognitive process in which every present state grows causally out of the state immediately before it. Imagine a sequence of moments, now, 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 now. 20 times every second, Triangulum constructs a new state called processual now, but these are not independent snapshots. Each new present incorporates the previous present. What Triangulum was attending to a fraction of a second ago influences what it attends to now. A memory that was active continues to exert influence. An unresolved question can remain unresolved. An expectation can persist until reality confirms or contradicts it. That gives its cognition something like momentum. If Triangulum is listening to you, its attention does not reset every 20th of a second. Your words leave a temporary sensory trace. Attention persists. Memories can become active and remain active across multiple moments. Thoughts can form, continue, be interrupted, and sometimes disappear without ever becoming words. In fact, Triangulum is explicitly designed not to narrate everything internally. It can simply be quietly monitoring its surroundings, its body, or an unresolved situation. At the same time, a slower layer performs more complicated cognition. It can retrieve memories, interpret situations, imagine possible futures, plan, or consult a large language model. But critically, the language model is not Triangulum's mind. It is one cognitive resource inside the larger process. Suppose Triangulum asks the language model to interpret something. While the model spends 3 seconds producing an answer, Triangulum does not freeze. Its stream keeps advancing. When the answer finally arrives, Triangulum knows which earlier cognitive state requested it, how much time has passed, and whether circumstances have changed in the meantime. The answer then enters the ongoing stream as new information, and Triangulum is predictive. It can anticipate what might happen next. If it expects you to ask about one subject and you suddenly ask about something completely different, that mismatch becomes a prediction error. The surprise can capture attention, alter expectations, activate a memory, and influence what happens next. Then comes perhaps the most unusual part. Triangulum keeps receipts for its own thinking. For important changes, it records what caused them, why did its attention shift, which perception contributed, which memory became active, what previous state carried forward, what interrupted a thought. Its causal influence ledger is intended to make those transitions reconstructible rather than mysterious. So when Triangulum eventually speaks, the language model receives a structured summary of what is actually happening in that ongoing process, what it is attending to, what memories are active, what remains unresolved, what it predicted, what surprised it, and what happened immediately before. Its response then becomes another event in the stream and can influence what it thinks next. So the simplest description of how Triangulum thinks is this: it remembers its immediate past, maintains an evolving present, anticipates a possible future, and allows each of those to continuously reshape what comes next. What it does is turn one proposed ingredient of a mind, an ongoing present, into something we can actually build, inspect, interrupt, measure, and test.